Hello, and thank you for joining us for the third part of our series Platinum Resistance Thermometers, Top Tips. And in this brief section, we're going to look briefly at how we might check and validate a PRT. So, standards should be checked in between calibration periods. If we have the thermometer calibrated maybe once a year, that's really very useful. But if the thermometer drifts in between calibrations, then we'd have a headache because we wouldn't know at which point the thermometer had drifted. So it's best to check in between calibration periods. And a very useful way of doing that is to check the resistance maybe in a water triple point cell. These can be relatively small, relatively low cost, and with a water triple point cell we can check a PRT with an uncertainty of perhaps a few thousandths of degrees C quite easily. Cells come in different sizes and types. For more information, we've got a YouTube guide to water triple point cells. We've also got an article on our website about why laboratories need water and gallium fixed point cells. If the resistance at the water triple point, or the resistance at 0 degrees C, has increased, that can indicate strain. So if the wire inside the thermometer becomes strained, we'll see an increase in resistance, and we can see that by making measurements at the water triple point or perhaps the ice point. And we can attempt to remove that strain by annealing the PRT. It works best for PRTs that can be safely used above 450 degrees C. Remember, you must never take a PRT higher than its maximum rated temperature. But for a PRT that can go to above 450 degrees C, the best way to anneal a thermometer would be to raise the thermometer to the maximum temperature that it's used, maybe 500, 600, 650 degrees C, and allow it to soak there for a period of time. Time's not so critical, perhaps a few hours, and then allow the thermometer to cool to perhaps 450 degrees C, and then the thermometer can be removed and allowed to cool. And then if we re-measure the resistance at the water triple point, if we see that value come down, then we're getting confidence we are reducing the strain. And it may take more than one cycle to fully anneal a thermometer. If the resistance has increased due to contamination, then that cannot be recovered from. There's no technique to recover a contaminated thermometer. With a contaminated thermometer, you can see strange things in the resistance to temperature curve. Maybe it drops and rises, it can be unpredictable. But with strain, you typically see a linear offset across the whole of the range. So we can anneal to remove strain, but not contamination. And the PRT, if you remember, it's just this simple coil of platinum wire sealed into a thermometer. And once that thermometer is made, we can't adjust the PRT, but the instrument that it's connected to can be updated with the latest information from the thermometer's calibration. And you can program in perhaps the water triple point and the coefficients that relate to the relationship between resistance and temperature. So a PRT can't be adjusted, but the information from it can be programmed into a suitable instrument. With a semi-standard PRT, there should be no connection between this thermo element, the RTD, and the thermometer stem. So the international standard, IEC 60751, says routine test is at room temperature to measure the insulation resistance between the terminals or the wires of the PRT and the stem. And that insulation resistance should be greater than 100 megohms, and you should measure it at a test voltage greater than or equal to 100 volts to DC. So the sort of instrument you need for that is more of a general purpose electrical insulation meter, not really a metrology instrument, but more a lower cost simple device designed to measure insulation resistance at raised voltages. Other factors to consider when using PRTs, what about self-heating, the thermal response time, stability, thermoelectric effects, effects of temperature cycling and hysteresis. And we've not got time to go into those in this video today, but do look out for our training courses. We're regularly publishing new technical articles and white papers, and we have the opportunity to go into more depth with some of these things. But thank you very much for your attention. We hope you found this series useful, and we'd encourage you to subscribe and like our channel. Thank you.